All right, so we're starting out with problems that were like the first example we looked at, where it has like distance traveled over a time interval. So something like number 2, a pump working at 15 gallons per minute, pumps for 1/2 hour. Or we could just say 30 minutes to, make life easier. How many gallons are pumped? It's not even the right class. What is happening? All right, so I'm going to set it up like the more calculus way to set it up, for delta S is equal to delta S over delta T times delta T, which is 15 gallons per minute times 30 minutes. So that's why I rewrote it as minutes instead of just 1/2 hour, because you obviously have to have the same unit so that they cancel. So then, minutes cancel, and we multiply, get, what is that, 450? 3 times, that is 15, carry on 3 times 1 is, yeah, right? Yeah. So 450 gallons. Simple enough.
Yes.
Good.
So far. So she wants.
Yeah, just give her 2 problems.
Okay. In exercise 11 and 12, use the 8 rectangles shown to approximate the area of the region below the graph of f of x is equal to 10 minus x squared over the interval.
More like 1 problem to next time.
Yeah, so my bad.
Trying to see. We did a right hand on the other day, right? So let's do a left one today. Actually, no, scratch that. I'm going to do a right one because otherwise, that way y'all have an odd one to do. There's only 2 of them, so. Okay. It's the same, like, setup, you just change the side of it. It's the only difference. So f of x is equal to 10 minus x squared over the interval -1 to 3, and it's broken up into 8 segments, or whatever you want to call them. 8 intervals, I guess is the right word. And then okay. You're going up to 10 on the y. So I was trying to count because it's like very confusing with already having it drawn. close enough. And then the intervals, obviously they're increments of a half. So this one, well, we're starting at, on the right-hand side at 3. And so you go up till you hit it, and then it comes over. The left would just start from the other side.
Oh, okay.
So, like, the left would start over here, and when you hit it, then you go over.
Okay.
So then... Oh, that was not what was supposed to happen. Obviously, these are given to you also, so you only have to really draw them if you want to. Yeah, these are kind of... What just happened? My whole curve just disappeared. Well, because these ones kind of go like a little bit over. So it's like... Anyways, close enough. Not an artist. For this, you can do the entire, I know, I was like, you
I thought you were like,
take that and just go. Like,
What?
I thought you were throwing up.
No, no.
I was like, oh no.
I was like, oh no.
You can do the table like we did when we did the other problem, but you don't necessarily have to have like every single little sub-interval written out and all of that, because that's just a lot. I would probably do like finding the height, and then the base is obviously all going to be the same because it's broken up evenly. And then do the area columns. I'm probably going to do the height column and the area column, and that's it. And I just know that I need to have 8 of them by the time it's done. So... because the base for all is going to be 1/2 across the board. So the height, remember we're plugging it into the equation. Now it is important that you know that it's the right hand side of it. So we'll start over here. So you'll have like, you know, -1/2, 0, 1/2. So it might, I mean, well, y'all see it better if I actually write the intervals. Okay. I won't write the base, but I'll write what the intervals are.
You don't always start off like on the right hand side, like, is that correct?
Right, this one is because it hits on the right and then goes over. So like,
Okay.
I'm gonna see if I can put it under here if you can see it. So like, look at 11 right here. So this one, make sure the iPad doesn't go off. This one, if it goes up and it passes on the right, you know it's not a right hand limit. So like, you always look at the 2 sides first. So it comes up on the left, and when it hits, it goes over. That tells you that it's a left hand one. So you would use the left endpoints, but on this one, I'm using the right because it hits on the right and goes over. So I'll have the interval from -1 to -1/2. I'll have -1/2 to 0. I'll have 0 to 1/2, 1/2 to 1, halfway there, 1 to 3 halves, 3 halves to 2, 2 to 5 halves, and then 5 halves to 3. So the number that's getting plugged in for height in this case is the right side. But in the problem that you have, it's going to be the left side. When I assign you number 11, you'll be looking at the other side. But the intervals are exactly the same. The drawing is just looking different because it hits on the left. So I'll have, obviously my function was 10 minus x squared. So I'm just going to write that there because that's what it's getting plugged into. So I'm going to have f of negative 1/2. I'm going to go ahead and write them all. F of 0, f of 1/2, f of 1, f of 3 halves, f of 2, f of 5 halves, and f of 3.
So then if it was left, you would use the...
I would use negative 1, negative 1/2, 0. Yeah. So other than the drawing, your problem will be exactly the same other than using the left. So everything that we're doing for the right, you're just replacing with the left numbers. So this one is the, obviously the right-hand one. So then we just plug this in. So 10 minus negative 1/2 squared, 10 minus 0 squared, 10 minus 1/2 squared, 10 minus 1 squared, 10 minus 3 halves squared, 10 minus 2 squared, 10 minus 5 halves squared, and 10 minus 3 squared. And I would just probably type that in your calculator. I mean, the ones that are whole numbers should be easy, but thank you.
Thank you.
Mhm.
Are you coming down to lunch to eat in there?
Yeah.
Alright.
6 and 1. Somebody help me with the fractions. And since ultimately our answers are going to be a decimal, you can just like write them as a decimal when you do them. I think that should be good and charged by now.
Yeah.
It's been on the charger for like a week.
Yeah. I literally just forget about things I have. Um, 9.7. 9 and 1. 9 and 3 fourths. For that one. It says. Okay.
You should put-
You got 10.5?
Well, 1/2 squared is what?
I wrote a square.
And then you need to do 10 minus that, because those negatives don't cancel.
Mm-hmm.
9.75.
Okay. Oh, we have to multiply them. So I was like, these numbers are going to be too big. This one should also be the same thing, I'm pretty sure. This one, the 3 halves one.
7.75.
And 5 halves.
3.75.
I thought we were done with the problem. That's why I was like, those numbers are not going to add up to the answer. And then I was like, oh, wait, we're not done. So now, remember, for area, we have to do the base times these numbers. So it'll be, I'm just going to make it 0.5 instead of 1/2, just so that we're in decimals for the whole thing. So 0.5 times 9.75, 0.5 times 10, 0.5 times 9.75, 0.5 times 9, 0.5 times 7.75, 0.5 times 6, 0.5 times 3.75, and 0.5 times 1. So then what are each of these? This one's 2. Half of 10 is 2. 4.5, 3. It's just the decimal ones that I need.
The first one is 4.8.
Okay. Oh, I guess the second one is also the same thing. 7.75.
Sorry, I'm so ready.
No, you're good. Josh has got it.
3.8.
And the 3.75 one.
1.82.
And then 1, 2, 3, 4, 5, 6, 7, 8. You just need to add these numbers up. Sweet. There you go.
It's overly tedious.
It is. Very much so. Partition the given interval into the indicated number of subintervals. So if you have the interval from 0 to 2 and it wants 8 subintervals, how would we divide that up? Two divided by 8 is what? 1/4. So we're gonna do increments of 1/4. So it would be like 0 to 1/4, 1/4 to 1/2, 1/2 to 3/4, 3/4 to 1, 1
All the way to go all the way to 8.
to 1/4.
Wait.
We need 8 of them.
Uh,
We're going to 2.
uh,
That would be miserable. Be more accurate, but it would be miserable. 1/4 to 1/2. Wait, nope. Hold on. Pause. Nope. This is 1 1/4. Okay, 1 1/4 to 1 1/2. And you could obviously, if you wanted to, like make these all fractions, but 1 1/2 to 1 3/4. Oh, it doesn't fit. And 1 3/4 to 2. But fortunately, you don't actually have to do the math. You just have to write them out. We could do the math for them, but
Like, no, though. Like, I'm not.
I think
that
y'all are gonna
enthusiastic.
pass on that.
Alright, I'm ready to go home and go to sleep.
We're not
all
done.
day.
you go to bed last night?
Huh?
I went 3. That's 3.
I wish I went to bed.
And then the night before, I went to bed at like 12, and then the night before it was 1.
You're a little
Also
rebel.
The night before before. It
I
was
know,
also
you're such a
one.
rebel. It's past your bedtime though.
You gotta be in bed by 8 o'clock. What's your bedtime? You can 8 point numbers.
Okay. Find the definite integral by computing an area. So this is like the last example we did yesterday.
Okay.
So 22, the integral from -1 to 4 of 6 dx.
I
It's
just
gonna
like
take up a lot of
drawing.
space.
I just like drawing integrals.
Running out of space.
No, I don't think these get that much.
So remember this is the area under y is equal to 6 over the interval -1 to 4. And our area formula that we had yesterday was h times b1 plus b2 over 2. So that's just evaluating at each endpoint this function.
Okay. Are we just putting it into the area form?
Yeah. So what's the difference between -1 and 5 or 4?
5.
5.
How?
4 minus -1 is
5.
5. So that's our height. So we have, this is equal to 5 times, well, there's nothing to plug in, so it's just going to be 6 plus 6 over 2.
Why is there nothing to plug in?
Because there's no x.
Okay.
Oh.
If there was an x, we would plug in the endpoints, but there's not an x in this one. So that's 12 over 2, which is,
6.
so 5 times 6 is 30.
Okay, we're so smart, guys. We did that basic math like champs.
And there's such an easier way to do this, too.
This isn't the
This
easiest
is-
one?
No, there's an easier way to do it.
What? Having the answer key? What? Like,
No, like actually solving the integral. We would take the antiderivative and then plug it in. So we would do the reverse of what we did the other day. So we would have, so 6 dx, so to take the antiderivative or the integral of that, we take and we put the variable, we like add 1 to the variable.
add 1.
So like there's no variable right now. That means it's x to the 0. So if we add 1, it would be,
X.
so it would be 6x. And then we would evaluate it from -1 to 4. So 6 times 4, 24 minus 6 times -1. So that would be plus 6, which is 30. It'll make your life a lot easier when the problems get bigger.
Okay. Yeah, because I was like, right now it's just.
It's not, and it's probably going to confuse you more, but it is an easier method, I promise.
Okay.
So it sounds like
I'll trust.
The way to
you.
check it is to then take the derivative of whatever you had, because ultimately you're going to be pulling numbers from in front of here to put up there, and it's okay. Don't worry about that method. Just ignore that. Forget that that exists right now.
Not real.
24.
it's all in your head.
The integral from 1 to 7 of 0.5 x dx. So this is the area under 0.5 x over the interval 1 to 7. So what is my height?
6.
Okay, so height is 6. So then we would have 6 times, we plug in 0.5 times 7 is, and you can give me the decimal. What's half of 7?
3.5.
3.5 plus half of 1
0.5.
over 2. So 4 over 2 is
2.
2 times 6 is
Still writing it.
12.
12.
Like I said, I have sleepy brain. So.
It's fine.
Still got there.
You did
So
get
the
there.
3.5
Was plugging in 7. So this is
7 times.
so this was 0.5 times 7,
Okay, because there's an X.
and then this was 0.5 times 1.
But you
Yeah.
only, you only do that when there's an X.
So if there wasn't an X, it would just be 0.5 plus 0.5 over 2?
Does the dx have any purpose, like, as it is right now?
No, but it does have a purpose.
So you get.
But we won't
your
get into that right now.
B terms by multiplying the 0.5 times the 7 superscript. And then you get the second B term by multiplying the 0.5 by the bottom subscript.
Yeah.
Using a big word.
So this is basically B1 and B2, but it's being plugged in to the equation. It's like, what just happened? 26, the integral from 1 to 4 of 3x minus 2 dx. So my height is
3.
3.
Why did you say it like that?
You got he was getting stressed.
Thank you.
Alright, so then 3 times, now I'm going to actually write this stuff as plugging it in because it's getting longer. So 3 times 4 minus 2 plus 3 times 1 minus 2 over 2.
I can't keep up.
There's too many parentheses, like.
Well, there doesn't necessarily have to be, but I want to make sure that it's like
Yeah.
evident what's happening. So
I just don't like it. It's just not a good look.
you'll like the easy method so much more.
I mean, I'm always for easy methods.
Yeah, but right now me trying to teach you the easy method's probably just gonna confuse you. So
Yeah.
you seemed confused on the easiest one, so I was like, yeah, maybe that's not the time for that.
Yeah. I wasn't ready.
It's like chapter 5,
Of what?
calculus. Maybe chapter 4 to do the easy method.
Wow, look. Where's
But honestly, the area method is very, very important. So if you learn this way, now it'll be a lot easier next year.
So we're just going through the whole calculus, but apparently if we learn that easy method.
Pretty much. So 12 minus 2 is 10 plus, what is that, 3? 1? Nope, not 3. 1.
One, it's one.
It's 1.
Yeah, thanks. 10 plus 1 is 11 over 2 times 3.
So 5.5. So 3 times 5.5 is, yes, 16.
What?
Crazy problem.
It's not the right answer.
No, that is. I'm looking at the next problem that I was going to do and trying to figure out how they got that answer. Trying to like do this in my head and figure out where they got this answer from, it's not working.
It's not.
But I realized where it came from, and we're not going to do that problem. It's an inverse trig function. We are not prepared for that yet. That's like chapter 6, I think, of the calculus book. So we're going to hold on that. And it's also this much of the AP exam.
Oh, okay.
Really?
Okay.
Yes.
Like one problem, probably. I don't know. Basically.
Okay. Yeah. We'll
Like,
figure
you
it
need to
out.
know it, but don't need to use it a lot.
Right now we don't.
We'll figure it out when we get there.
Right.
We will run away from that bridge until we must cross.
Run away from.
Sprint.
Or sprint the other way.
Sprint the opposite direction. Does book one have a choir quiz today? Do you guys have quiz today or no?
I don't know.
I think
If
so.
we did, I'm not taking it.
I think you have to take it to mix that. I don't think you
I'm
get to
gonna,
choose.
I'll take it tomorrow.
Oh no. Oh no, that's
What is that?
Not inverse trig, but still trig.
You know how I feel about
You know how I said that I liked sine, cotangent, like sine, whatever the rest of it is? Cosine and tangent. I don't like them in this.
I don't even know what I'm reading. Okay.
You people know how I feel about it.
I like it, but like not when it's mixed with
Other letters.
it's
Ooh.
I just don't like letters in math, okay?
Well, they're past like okay. Well, my sister has letters in math now, and she's in 4th grade.
Yeah, exactly.
So.
That's just terrible.
She doesn't like past
Let's
3rd
go back
grade
to
math.
like 1 + 4. I'd be okay with it.
All right, so the height of this would be what?
3.14. Wait.
Pi.
Pi minus 0, which is
Yeah, I guess. I didn't know if you wanted the number.
No, I just want pi. All right, so now I'm going to do the same thing, but plugging in. So pi times, okay, I'm going to again write it all out. Sine of pi plus 2 minus, or no, plus, sine of 0 plus 2 all over 2.
Hey.
so like
In calculus, you don't get a unit circle.
That's why I'm racking the brain.
it's 1.
It's either 0
Where's pi?
or -1. It's on
Pi's
this
like
side.
Okay, what is y there?
0.
0.
Okay, so I was right. Okay, cool.
0 plus 2
No.
plus sine of 0 is
Hold on.
Like 0.
0
Okay.
plus 2 over 2. So then that's 4 over 2, which is 2, so it's 2 pi.
Will we get a unit circle in our quiz?
You don't
Do
We're
you need
technically
one?
Still in pre-cal.
Oh wait.
We technically still are.
Yeah.
Not-
I'll think about it. If I give you a trig one, I'll think about it. I might not give you a trig one. But I mean, if you want one, I can always give you one. But.
Like, I didn't, like, no, we didn't say anything. I don't know.
Thoughts I said, if you want it, I can give it to you. But if you're like, I don't have to.
It's like a security blanket.
The unit circle. Yeah.
It's like your best friend that like goes off to college next year.
Yeah.
No,
Oh,
honestly.
dang. That's so true.
Honestly, that's such a good analogy.
That's what happens because you don't get one on the AP exam.
That's
So
messed
it
up.
goes bye-bye.
That's so rude of them.
You know what? They can go
That
bye-bye.
disrespect.
All right.
I've been using it for like 3 years. Like, definitely should not have memorized by now. I can write it if you give it to me. Like, if you give me the circle, I can write it. But like, remembering which one.
1, 11, 13,
Honestly, I think this section was
21,
easier than-
23, and 25.
What was last?
Yeah, I think this section was